Howdy folks, friends, neighbors. Let's have a little discussion on antiderivatives and logarithms. It's meant specifically for AB students. AB students only. Well, let's recall what we talked about yesterday with the function ln of x. This is what the function ln of x looks like, and what we want to notice here is that the domain of ln of x is all x such that x is greater than 0. You can't log a negative. So this is the domain of ln of x. Keep that in mind. And what we discovered yesterday, well, we didn't discover that. What was given yesterday was that if I have this function ln of x, the derivative of ln of x is 1 over x. This was given without a proof. We did have some discussion about the graphical representation of the derivative of ln of x, but this is what we determined yesterday. The derivative of ln of x is 1 over x. Well, it certainly follows then, by the definition of the antiderivative, that the antiderivative of 1 over x would be ln of x plus c. The antiderivative of 1 over x dx is equal to ln of x plus c. That makes sense. Certainly follows from the definition of the antiderivative. Well, is that true or false? Well, I'm going to tell you that this is, yeah, it is true or false. And let's think a little bit more about that. If I look at the graph of ln of x, this is my claim here. This is what I have a big question mark here. Is that true? Is the antiderivative of 1 over x ln of x? Well, if I look at the graph of 1 over x, the graph of 1 over x, the domain of 1 over x, is all x such that x does not equal 0. This is a simple rational function. We learned last year and several times this year that the graph of 1 over x is this always decreasing function that explodes down at 0, it explodes up as I approach 0 from the right, but this is the graph of 1 over x. Well, certainly then, since 1 over x is defined everywhere at x equals 0, and it is, it's defined everywhere, except at x equals 0, it has to have an antiderivative. Where? Well, everywhere except x equals 0. It's got to have an antiderivative everywhere except at x equals 0. If that's the case, how can this be true? Because that dude there is only defined when x is greater than 0. So this can't be completely true. The way we handle that is very simple. Bam! We let the antiderivative of 1 over x simply be ln of the absolute value of x. Now I'm always ln'ing a positive number, and that's the story. If x is negative 5, ln of negative 5 is going to be ln of absolute value, negative 5 is ln of 5. So this is the way I handle this. And this is the formula that I need, this is the antiderivative, this is the antiderivative that I need to commit to my memory. That the antiderivative of 1 over x dx is equal to ln of the absolute value of x plus c. That's what I need to commit to my memory. That's what I need to realize is a school bus. The antiderivative of 1 over x dx, ln of absolute value of x. That's the school bus that I need to memorize. Okay? So let's just do some examples knowing this right here. Using this right here. Example number 1. Here I have a definite integral. I want to evaluate the definite integral from 2 to 5 of 6 over x dx. I could do this with my calculator. I could do that with my calculator, but let's find out what it is exactly, if I can do it. Well, this is a constant. The 6 is a constant, so let's write that as a constant. So this is going to be 6 times 1 over x. This is the same as 6 over x. So I'm looking at, really, the antiderivative of the definite integral from 2 to 5 of 6 times 1 over x dx. And I know, or at least I should know, that if I have a constant times a function, I can pull that constant out. And it's not going to affect the definite nor indefinite interval. And I'm going to pull that 6 out right there. And so now I'm looking at, this is going to be 6 times the definite interval from 2 to 5 of 1 over x dx. What's the antiderivative of 1 over x? ln of x. No, ln of absolute value of x. So this simply is going to be then 6 times ln of absolute value of x evaluated at 2 and 5. And I'm going to employ fundamental theorem of calculus part 2. So this is going to be 6 times ln of absolute value of 5 minus ln of absolute value of 2. Absolute value of 5 is 5. The absolute value of 2 is 2. So this is going to be 6 times ln of 5 minus ln of 2. And now I can do that property, use one of those laws of logarithms, and write this guy here as ln of 5 over 2. So the answer then is simply going to be 6 ln of 5 halves. Okay? Example. Next example. Let's zoom out on that baby a little bit. So we can follow along. Let's zoom out and let's look about this guy right here. Here I'm only finding an indefinite interval. I want to find the indefinite interval of 5 plus x cubed over x to the 4th dx. And what we need to realize in AP Calculus AB is we're never going to be able to anti-differentiate a quotient. So we're going to have to do something with those quotients when we see them. We're either going to have to use substitution or manipulate the quotient so that it is no longer a quotient. And that's exactly what I'm going to do here. I'm going to use the definition of addition of fractions. And I'm going to write this 5 plus x cubed as 5 over x to the 4th plus x cubed over x to the 4th like this. So this is just this is an algebraic true statement. Okay? And now I'm going to write this guy as the antiderivative of that. Well, sorry, get a little ahead of myself here. And now I'm going to get ready. I'm going to need to write this in a way that I can anti-differentiate it. So I'm going to write this 5x to the negative 4 plus 1 over x. And you'll see in a moment why I'm doing that. Okay? Therefore, this antiderivative of 5 plus x cubed over x to the 4th dx is equal to 5x to the negative 4 plus 1 over x dx. And now I'm just going to use that formula. The antiderivative of x to the n dx is x to the n plus 1 divided by n plus 1. And so negative 4 plus 1 is going to be negative 3. And I'm going to have 5x to the negative 3 over negative 3 plus the, what's the antiderivative of 1 over x? ln of absolute value of x. So I can write this, I can clean this up a little bit. I'm going to put this guy on bottom and make the whole fraction negative. So this is the answer to that. That's the antiderivative of this dude right there. So this, what did I have there? 5 plus x cubed over x to the 4th dx is equal to this dude right there. Okay? Let's do another example. And let's look at this dude right here. This is a definite integral. And I want to find the definite integral from 1 to 4 of x squared plus x plus 1 over x dx. Again, I have a quotient. I need to do some algebraic manipulation of that quotient, and it's going to be the same process that I did the last time. I'm going to split that quotient up. I can only do that, keep in mind, if the denominator is a single term. That's the only way I can do that. That's an algebra law. But anyway, this is going to be, what I'm going to do first is find the general antiderivative of x squared plus x plus 1 over x. And I'm going to split that up, just like I discussed, as x squared over x plus x over x plus 1 over x. Ooh, there's that ln of x. X squared over x is simply going to be x. X over x is simply going to be 1. So that's going to be x plus 1 over x. And now now this is a very simple thing to anti-differentiate. The antiderivative of x is going to be x squared plus x squared over 2. The antiderivative of 1 is going to be x, and the antiderivative of 1 over x is ln of absolute value of x. Okay, add 1, divide. Well, the derivative of x is 1, and 1 over x is ln of x, absolute value of x. Keep in mind what I wanted to know is I wanted to know that definite interval right here. And so this definite interval from 1 to 4 of x squared plus x plus 1 over x dx is equal to x squared over 2 plus x plus ln of absolute value of x evaluated at 4 and 1. And now I just need to be very, very careful in my evaluating this using the fundamental theorem. So this guy here, this is going to be that capital F of B minus capital F of A. I'm going to put 4 in. 4 squared plus 2 plus 4 plus ln of absolute value of 4 minus. Now I put the 1 in. 1 squared over 2 plus 1 plus ln of absolute value of 1. This guy here is going to be 0. 4 squared over 2, I think that's going to be 8. Plus 4 plus ln of 4, absolute value of 4 is 4. Minus 1/2 minus 1. If I simplify that algebraically, it's going to be 10.5 plus ln of 4. Okay? And at any time know that this is a video that you can stop and pause and write your steps down. Okie dokie. One more example, we'll conclude our discussion about this. And hey, oh my, look at this dude right here. Say I want to find the antiderivative of cotangent x. And I'm looking over there at my board of my derivatives and antiderivative of trigonometric functions, and I'm looking, and I see that there is no antiderivative for cotangent x. So what, can I still do it? I don't know, let's see. Let's write it. Hey, cotangent x is the same as cosine x over sine x dx. So let's see if we can evaluate this using some substitution. And I'm going to let u be the bottom. I'm going to let u equal sine of x. And if u is equal to sine x, du is going to be cosine x dx. Derivative of sine is cosine. This differential du is cosine x dx. Let's use these two equations, do some substitution over here. And so therefore sine x is u. I still have the cosine x dx on top. Cosine x dx is equal to du. So I'm really only anti-differentiating 1 over u du, which I know is ln of absolute value of u. We can add a constant of integration if we so desire. And so now what do we have? Well, what do we have? We have the antiderivative of cotangent x is equal to ln of sine of x plus c. Again, this is, we're very uncomfortable with this, but that's okay. We're allowed to be uncomfortable with some things. So, what I've given you is some examples of when we're going to see this antiderivative of this right here. Let's go to the slide. This is all you really need to know. Is this statement right here. The antiderivative of 1 over x dx is the natural logarithm of the absolute value of x, of course, plus a c. Do a few exercises, get used to using this. This is what you need to know, and that's all that you need to know about antiderivatives and logarithms.